morning to you, and you know that just looking back to the previous class, some portions we have been discussing about boundary layer, and we discussed about boundary layer, laminar boundary layer, turbulent boundary layer, and Reynolds number normally associated with this type of boundary layers which we discussed, and this is a figure which we have seen in the last class, which shows the boundary layer where it is laminar in the forward side, and it picks up to a transition and then to the turbulent boundary layer, and the boundary layer increases its thickness towards the aft. And we also seen in our previous class that the boundary layer separates towards the aft, and subsequent effects also we discussed in the one of the previous classes. So then we have shown that wave systems generated by ships through these slides in the last class. Then coming to the speed and power requirement, depending on, you know that when the vessel is waterborne, the resistance is more. If we can partly bring it out of water, then the waterborne area will become less, and thus the resistance will be reduced. So which implies that the vessel can attain a higher speed with the same power. So there are vessels which use this advantage to put it above the water and then attain high speed. So here this is a comparative study. This diagram here shows a comparative study between the various types of vessel. You can see it is a bulk carrier here which is coming at the bottom, then fast cargo vessel, destroyers. Most of these vessels come under the displacement. You can see that this is coming at the displacement. You see the displacement type of vessel resistance going up. You can see that effective horsepower per ton requirement is plotted here and against the speed basically over here. So when the speed go beyond a limit for a displacement vessel, the power requirement shoots up drastically, asymptotically, and it's become difficult for a displacement vessel to achieve high speed. So if you look the other type of vessel, this is a destroyer type which is more fine in shape, again also comes under the displacement type, whereas these two vessels come to deep displacement. This is not so deep displacement. Then you consider another vessel called planing craft. Planing crafts are one which is having a hydrodynamic effect. Maybe I should give you picture of that in another class. Maybe when we discuss with the resistance of advanced vehicles, we will see that. And here the power requirement, you can see that a particular EHP per ton, if it is 40, you just take, or you just take 30. So deep displacement vessel can take only a speed of V by root L of 2, whereas destroyer is slightly higher, and if you look the planing craft for the same power it attains a much higher speed. And thing is much better for the case of a hydrofoil craft. You can see this hydrofoil craft. Hydrofoil crafts, that means it has got foil beneath the vessel, which when moves forward through water it generates a lift, and this lift puts the vessel up, puts it up above the water. So the resistance comes down drastically, and due to that it can attain higher speed with the same power. So there are two types of hydrofoil. So it is a surface piercing, and the other one is a submerged foil type. So at high speed you have the vessel attains a operating situation which you call, it is a foil borne condition. Only the foil is beneath the water, and the whole hull is lifted above the water, and thus bringing down the resistance, and hence enabling you to have high speed for the same power. So you can see the difference. For if you consider here, you see the displacement vessel, what is the speed is achieved for the same power, then for the destroyer type, then you have for the planing hull and then the hydrofoils. So there is an innovation and technology still getting advanced. There are more type of vessels coming up, air cushion vehicles, surface effect ships. So there are different types of methods, technology advancements using which the resistance of the vessel can be brought down and it can achieve a high speed for less power. And you know that this new generation, there is a lot of demand for passenger ferries. You know, passenger vessels, we will see maybe in subsequent slide. Passenger ferries and passenger ships, the difference is passenger ships they go at relatively low speed, usually cruisers and all that you go at about 25 knot speed, big vessels, whereas the passenger ferries are smaller vessels compared to the passenger cruisers, and it is for basically meant for commuting people, that is particularly after the formation of European Union. You know, people in one country of the Union can work in another country, so they can stay in one country, maybe stay in UK and maybe they want to work in France. Should be possible if they can commute the distance within 2-3 hours. So naturally the demand for fast passenger ferries got importance, and people are looking into the achievement of higher speed to cater to the need of these people. So that is a place where you have to look into reduced resistance and higher speed options. Okay, here it shows the submarines and submersibles, and you can see that here the growth is relatively less compared to other types because it is submerged and there is no wave making, and hence even at higher speed it does not shoot up as it does for surfer ship. This is a comparison for displacement vessel. You can see for the displacement vessel, and this is a resistance and resistance and against the speed here, speed length ratio. You just to give an indication how the frictional component, the major two components which we discussed as part of resistance are friction and wave making, and here you can see that how these components matters in the case of depending on speed. You can see that speed when it is very, here it is speed length ratio of 0.4, the wave making effect is insignificant, and when it grows, the speed picks up, you can see that the wave making is picking up, and at some stage you see that it is crossing or exceeding the frictional component. So this gives an indication that how the speed influencing the resistance and which component dominates at higher speed. So look to the ship and powering aspect where that this shows the classification of ship types, different types of ships. How do you view from the perspective of powering? How do you identify this? So first we will have a look, see the types of ships. Here it is a high performance vessels. We have already mentioned hydrofoil craft, planing craft, ACV air cushion vehicle, and maybe one more, maybe SES surface effect ship. So here the hydrofoil craft moves at a higher speed, usually small craft, and due to the hydrodynamic effect there will be a, there will be a hydrodynamic lift, it pushes it up partly above water, and compared to the displacement condition, so which reduces the resistance and enable the resistance. So here what you have to do is you have to find out what is the actual displacement of the vessel in a displacement condition, and what is the underwater portion or submerged portion when it is in the planing condition. So which enable you to find out the resistance of the vessel. Then that is against planing craft. I am sorry, this I was just explained this planing craft. When it comes to hydrofoil, again you have a displacement mode because initially it is fully waterborne. So it has to attain the speed to get a threshold, so that the velocity of flow to the underwater foil is sufficient to generate a lift and push the vessel up. So that power also should be estimated, that is what is the power required at the transition region, that is shifting it from displacement to foil bound condition. So that again that means resistance need to be estimated for different operating conditions to find out the power requirement, then to select the engine and then to design the propulsion system for that. Air cushion vehicles are again another concept. ACV generally you know the typical thing is hovercraft. Hovercrafts, they generate a cushion where there is a skirt around the vessel, it generates a cushion by fans. So because of the amount of pressure, air pressure, the hull lifts up and the hull goes to will be in contact with, not in contact with water, only the skirt in contact with water to make the chamber an air chamber. And this being the case, that is the hull has gone up, then the resistance comes down because now it is air resistance primarily, and reduced resistance results in higher speed. So this type of vessel usually use, because it is above water, use air propellers, not water propellers, hovercrafts. So that is the air cushion vehicle. And one more surface effect ship which is usually a catamaran type, very fine shape, and the end of the catamaran, open catamaran region is covered with the skirt and they forms a chamber and air pressure inside is created using fans, and then it performs more or less similar to air cushion vehicles. Then the fishing vessels, other type of fishing vessels. Fishing vessels, there are a lot of types of fishing vessels. Many vessels come under the class of fishing vessels. Some of the primary type are the trawlers, which used for trawling operation. Trawling, these type of trawlers, they have a net attached to it, and the vessel moves with the net open across a school of fish which has been previously identified, and the school of fish moves with some speed because the whole mass of fish moves with a particular speed, and usually it may be 2 to 4 knot speed for the fish school. So what you do is the fishing vessel net has to operate at slightly higher speed so that it overcome the speed of the fish, and also if the speed is more than the fish speed, the fish once it caught inside the net will not escape. So that is how it is done. And trawlers, that means it has to go from the fishing ground, I mean from the harbor, fishing harbor to the fishing ground. So that should be a free running condition, that is a vessel, a fishing vessel operates from the fishing harbor and it goes to the fishing ground maybe few nautical miles away, tens or maybe even 100 nautical miles away. So that region, it will be a transit region will be a free running condition. So once it is in the fishing ground, then the speed of the vessel should be reduced so that it encircle the fish school and catch the fish using the net. So while doing so, there are two aspects. One is the resistance offered by the fishing vessel, and other one is the resistance offered by the net with the fish inside. So it is a different operating condition. So whenever you do resistance estimation for fishing trawlers or the power requirement, power estimation for fishing trawlers, it has to be done for the two cases, that is in the free running condition and also in the trawling condition. And also when it is the return trip, now it is loaded more, so that means the displacement is more, and you have to look into that aspect also. So you would like to have the fish, caught fish as soon as possible back to the shore, so that the fish can be kept as fresh as possible, and then it can be taken for processing and marketing. So that is a trawler. So trawler, when you do the resistance calculation, you have to consider the free running speed condition and also the trawling condition. When it comes to the next type called purseiners, it's a is basically making a purse. You identify a large school of fish, usually it's a small fishes like sardines or mackerels and all that. So you identify it may run into maybe kilometer size or such a massive school of fish. So these vessels, Persinus usually have a net which will encircle the whole school of fish, and that is a small boat is used to launch it from the mothership, and it takes one end of the net and encircle the and bring it back to the mothership. Then there is a beneath bridle which will be tied up, so it is brought down closer and purse is formed. The whole fish is now trapped inside the purse, then they make it small and then it is usually pumped into the fish hold then process. So that is the one. So here the power requirement comes only when the vessel is in free running condition. The power requirement during the fishing operation is not high. Long liners, again it is a long lining, it is a line of net, you must have noticed somewhere, it is like a wall of net which is laid across a stream. When the fish try to cross the net, it will get entangled by its gills, and that is what, then the net is removed and fish is taken on board the vessel and subsequent to processing or cleaning, washing, storing and all that. So long liners also primary consideration or from power point is, it is power estimation is, it is from the free running condition. So whale catches, you know that catching of whale is banned now, and Japanese are it's their favorite whale. So whale catching is allowed only for research activities now if you want to do some research, but I understand that Japanese do a lot of catching and they brand it as for research, so naturally they are consuming it. So here this whale catches, whale is runs into maybe huge, so you do not go for multiple catch, you just catch only one whale at a time. So the handling is also difficult, this type of vessel. So usually the fishing vessels, fish is caught and it is loaded on deck, but whale is unable to, you can't load it on deck. So this under that is a bottom of the vessel, it has a provision to open, the bottom opens, the whale is brought in, close the bottom, and that is how it is taken. So that is a whale catcher. Whale catcher again you have to look into the powering aspect when it is in the free running condition. Then the fish factory vessel is the one where the fish is caught, it can do catching fish, or also it can be a part of a fleet of fishing vessels. So you have many fishing vessels operating in the same region or maybe in different region, the fish is brought to this factory vessel. The factory vessel have all plants, the plants for processing, canning and everything may be there, storage and everything. So it does the central processing of the caught fish. So here the power requirement become a free running condition and also the power required for the plant machinery and all that. So you have to look into that power requirement. It may be an auxiliary machinery devoted for the plant, or maybe it is a power takeoff from the main engine depending on the type of processing, capacity of processing and everything. So this is a power requirement for the fishing vessel. Then comes the harbor craft. Harbor crafts, tug is a major one there, you can see that tug, harbor tugs are different types, ocean going tugs, harbor tugs and all that. Harbor tugs confining primarily to harbor region, assisting big vessels to move from berth or getting to the berth and all that. And ocean going tugs, it has to go in a free running condition. So it is a harbor tug, the power requirement may be mainly when it is the Toro pull condition or maybe in the bollard pull condition. So that is the requirement for harbor tug, and power propulsion system also it differs for harbor tug where the controllability is more important and free running is less important for harbor tug. Dredges, most of the harbors, waterways need dredging operation, dredges do that. There are different types of dredges. The power requirement free running is normally less because dredges usually do not go for a longer free run situation. The main operation is dredging and the power requirement will be decided based on the dredge machinery power requirement and also hefty pumps on board the dredges which pump out the the sludge dredged from the waterway bed. Then you have the pilot craft. Pilot crafts are mainly for piloting vessels from outer harbor. When the ship comes to the outer harbor in sea, a vessel will go with a pilot to guide the vessel to the port. So that is the purpose of pilot vessel, and pilot vessel you normally go by the free running condition. Buoy vessel mainly used for as a buoy, is a laying buoys, and buoys are used in harbor region for identifying the waterways. That is a navigational channel to identify, because that is a place with the deepest region where mainly the big ships, when they come in, they should have a clear idea through which it has to maneuver. Then coming to cargo ships. Cargo ships we can widely classify into dry cargo and liquid cargo ships. So under the dry cargo is a general cargo ship. General cargo ship can carry any type of cargo, that is what it means. It can carry liquid cargo, it can carry dry cargo, it can carry grains or whatever it may be. Only thing, in all the cases it will be unitized. That is, if you want to carry grain, you have to put the grains in sacks or bags, and if you want to carry liquid, it will be in barrels. So that means you can carry everything, and also a lot hefty machineries, steel plates, sections and everything are being carried using dry cargo. A lot of things are required. If you need, if you have a shipyard, most of the Indian shipyards, they import steel and machinery from abroad. So these things are usually carried using a general cargo vessel. So general cargo vessel, which normally operates conventional vessels, all these vessels which we discuss here, most of the vessels, they have a different majorly 4 operating conditions are considered. That is, you consider the fully loaded departure condition, fully loaded arrival condition, then ballast departure and ballast arrival condition. These are the 4 conditions. So fully loaded departure condition is the one with the maximum displacement. So when it is a departure, means the stores are full, fuel is full, water, fresh water, everything is full. When it reaches the other port, maybe 80%, 90% of the stores are consumed. So that is why, that means hundreds of tons of fuel it has been consumed. So the displacement is different. When it comes in the ballast condition, it is lightly loaded, because no cargo, unloaded the cargo, and on the return trip the displacement may be 35%, 40% of the maximum displacement. So when it comes to the power estimation, you do the power estimation for the maximum displacement and at the service speed. So that is what is done for the general cargo. So same thing for bulk carriers. Bulk carriers are the type of ships which carries dry cargo in bulk. Bulk means basically it's a loose form. So wheat carriers, or in general say grain carriers, in loose form, no sacks, nothing required, just pour it into the ship hold and carry it. And also there are different types of bulk carriers, ore carrier, a sulfur carrier, then any cement carrier. So all these are come under dry cargo carried in bulk, which are classified as a bulk carrier. There are sub classification for bulk carriers. We are not going to details as it is not required here. Container ships is relatively a new generation ship compared to other types of ships. Containerization which has got evolved for faster and faster transport, basically spends less time in port, because the containers loading and unloading is rather easy compared to other type of cargoes. So these vessels, the fastness is important, so the speed of the vessel is also much higher compared to other types of ships, whereas general cargo and bulk carriers, the speed may be around 14-15 knots. Container ships comes about 25 knots. So container ships hence become much fine in form compared to bulk carriers and other general cargo ships. Ro-ro ships are roll on roll off ships, that is the cargo is roll on and roll off. There is no crane required, that is for transport of car, vehicles, locomotives and all that, these type of vessels are used. So here if you look to the picture, the space requirement is much more compared to the weight. because then actually the freeboard of the vessel, that is above water portion of the vessel, is much higher. So the wind resistance will be more for this type of vessels. The same thing for container ships also. Container ships, nearly 50% of the containers are loaded above the deck. So the above deck, you must have seen pictures or actual container ships, the exposure to wind is much, the area exposed to wind is much more, and hence the wind resistance will be much more for container ships, and the same thing apply for ro-ro ships. The same thing may apply for passenger ship too. Then the other class is the liquid cargo. The liquid cargo under which you consider crude oil carriers. Crude oil carriers usually very full form, block coefficient about 0.8, 0.85 or even more. The biggest ship ever built is a crude oil carrier, and I think the displacement is 550,000, not displacement, dead weight is 550,000 tons. So you can just imagine its size is around 450 meters I think long, and 70 meters or more wide and all that. You can just see that it is a floating island, moving island. So such a massive ship, so when you estimate the power requirement for that ship, it will be enormous if you look at the displacement and all that. So then the product carriers, petroleum product carriers, that is which carries diesel, petrol after from the refinery. Crude oil go to the refinery and product come from the refinery which is being transported. LNG carriers, liquefied natural gas. So gas is easy to carry in liquefied form, otherwise the space requirement is high. So you compress the gas or maybe bring down the temperature of the gas chamber so that the gas get liquefied, or use both, partially compress and partially reduce the temperature. So it is stored in a, normally it is a very low temperature, and carrying this type of products is a risky business. So because a slight change in temperature can make fumes and it can lead to explosion, high pressure develop inside the container, and also this being under low temperature, the material which you choose should be able to perform satisfactorily under this temperature, isn't it? If you normally a ship is built using mild steel, if you use mild steel, normal shipbuilding quality steel for LNG containers, then naturally LNG is kept at very low temperature. The mild steel, which is ductile in nature, when it is at low temperature, that means if you dip in liquid nitrogen, the steel will break like glass, so it becomes so brittle. So such type of material cannot be used for this container, so special type of material. So LNG shipbuilding is a very highly skilled and specialized job, and very few countries in the world go for LNG vessel construction. Then chemical tankers, again it's a liquid carrying liquid chemicals, maybe a benzene carrier, phosphoric acid carrier, or sulfuric acid carrier, or any chemical liquids which are being carried in liquid form. It is called, it comes under chemical tankers. Water carriers, which carries drinking water normally, because mainly in the Persian Gulf region, some countries there is shortage of drinking water, and it is transferred from one place. What I understand from water is transferred from Iraq to maybe places like in UAE and all these regions. So water transport, water carriers are used, again comes under the liquid cargo vessel or tankers. So in all these cases you have to see all these liquid carriers usually run at low speed, maybe 15-16 knots, and the resistance for these vessels depending on this fullness, most of the vessels or these liquid carriers are full form, so the resistance will be more from the frictional side, and form resistance will be more because of the fuller form. We have already discussed that form resistance, what is the component, and wave making resistance, if it operates at high speed it will become very high, and that is why the speed of the such type of vessels are not put at high, it is at low speed. If you remember the previous slide where we have seen that the resistance shoots up with the increase in speed for displacement vessel, then that part, better avoid that part of the speed. Passenger ships, another category, there is a cruiser ship. Cruiser ship is a pleasure craft, is a pleasure vessel, it is not a craft. You must have seen Queen Elizabeth and other type of passenger ships, very luxurious ships, which can have maybe a 5-star hotel facility inside, a lot of facilities, shopping facilities, swimming pool and everything. So this is for pleasure activity, people go around the globe, maybe spend months together in the ship for enjoyment. So this, the usual speed is 25 knots in that range, and it is a big ship, and the power estimation, power requirement and resistance estimation depends on the displacement type of vessel, where you have to consider the frictional resistance, then the wave making component. These are the major components, and accordingly you decide about the power requirement for the main engine. Then passenger liners, we have already discussed that cruiser. Okay, when you coming to the cruiser, you know that it is operating across the globe, and one of the aspects which we discussed in the previous class is that the seaway effects on resistance. So when you design a cruiser, you have to consider different locations of the ocean through which the ship is put to operation. You have to understand what is the motion characteristics, what would be the added resistance coming to the vessel, and which will go as an input into the total resistance estimation and subsequent choice of the main engine. So when it comes to a liner, when you put a liner, we often say it's a cargo liner or passenger liner. It's a liner. When you say it's a liner, it is going to operate within specified port. If the vessel is going to operate from Chennai to Singapore and it's meant to operate only in that region, you call it a liner. So that means the sea state is for that region only need to be known, and you have to make the assessment for the motion characteristics in that region. So that is usually the liner. Sometimes they call passenger liner, or if it is a passenger ship operating between specified in a specified route, specified between specified ports. Passenger ferry, I have already explained. Ferries, that is, it's for short trip. It's not for long trip, maybe 3 hours, 4 hours trip, and usually used for commuting. Some fast ferries are there, and slow ferries are also there. If it's in a harbor ferry, just transporting people from one place to other, from maybe one island to other, it's not far off. So then it's a low speed, and if it's a the case which I said before, like in the European Union or also in the US, you have this type of fast ferries. I think we don't have fast ferries in India operating, but there is no necessity as of now. And maybe if you go for a union of what is that, SAARC, South Asia region countries, then maybe things may come by people in Calcutta or maybe somewhere can go and work in Bangladesh or Burma or somewhere. And then passenger boat again is usually small craft or just commuting passengers, boats. So in all these cases the resistance matters when it comes, or it's almost same as a displacement vessel. When it comes to fast ferries, then you have to consider the high speed. The speed of the vessel comes to about 65-70 knots nowadays for the fast ferries. So you just imagine it's an enormous speed. 70 knot means it comes to about nearly 130 kilometers per hour, and through water is very high, not like through land. Then pleasure crafts, there are different types of pleasure crafts. So all this the resistance estimation depends on the type of operation, type of vessel, and the speed of the vessel, all matters in the estimation. When the speed is high, you make because the wave making resistance become higher, and you have to take care that the wave making is brought down by fine tuning the form of the vessel. Warships is another category. There are different types of warships: attack crafts, destroyers, minesweepers, landing crafts, aircraft carriers, and many more. So depending on the operation of these type of vessels, again you have to look into I am not going to item each category wise. So this is general. So you have to look into the type of vessel, its operation, type of operation, whether it is going to have a single mode of operation, or like tugs it will have free running, like fishing trawlers it will have free running and also a towing condition. So you have to look into the different operating conditions of the vessel, and based on each operating condition you have to make a power estimation and go for the highest power required depending on the type or stage of operation of the vessel. So naturally there is no limit for our achievement of limit, means our wish, or we should say maybe we are more greed to have more speed. The higher the speed is our wish. So when the US invaded Iraq, they preferred to have a vessel with 100 knot speed for transport of military items to Iraq. So 100 knot speed, it's as of now it's not achievable, but the trend shows that it can be achieved. So now you have to find out ways of achieving the speed, like the aircraft, the Concorde aircraft, supersonic passenger craft, airplane, which has been grounded because of other reason. So you go for higher speed, that is whether it's aircraft or whether it's for ships or even for surface vehicles and all that, you prefer to have high speed. So here, as I discussed before, the surface ships, that means the ships which operate at the surface, free surface, vessels operate free surface, where the wave making is also important. So how to, depending on the support, there is aerostatic support. If you look to here, air cushion vehicle, which I have already explained. Unfortunate thing is I do not have the picture here, maybe next class I will show the picture. In these two types, because of the creation of air cushion, the vehicle get pushed up, contact with water become less, and the speed become high. So you have to look to the resistance estimation of these vessels when it is in airborne condition, and air resistance become more also important for that, whether air resistance is a very meager quantity in case of conventional ships. Other one is hydrodynamic support, where you say hydrodynamic support, under which comes hydrofoil crafts, planing crafts. I have already discussed what are these. Maybe I will show you some pictures later, and just to give an idea what these type of vessels look like. Then displacement vessels, under which again you have a monohull, that is a single hull. Most of the ships which we discussed are single hull, that is cargo vessels, passenger ships, and most of the things we discussed are single hull. But there are multiple hull vessels, even passenger vessels and even some research vessels and all that. Catamaran having two hulls, the two hull catamaran. If you have three hulls, that is a main hull and two outriggers, it's called trimaran. Then same thing, if you have a main hull and I think of 4 outriggers, we call it, that is 4 plus 1 5, it's called the pentahull, pentamaran. And then you have this swath, that is swath is the small waterplane area twin hull ships. So these are the other types of ships which use for reducing the resistance and also increasing the performance of the vessel, like that, depending on the type of its use.